Hello everyone, I'm Matias Clunes from the Pontificia Universidad Católica de Chile, and today I will present you part of my PhD research entitled Dike-induced ground deformation influenced by the orientation of geological strata, insights from numerical modeling. Our research is focused on understanding the mechanical interactions during magma propagation and emplacement in undercrustal segments. The starting point of our research was to try to understand the influence of a crust made by inclined layers due to folding in the Chilean Central Andes in magma emplacement and propagation. We observed from field observations and numerical modeling using the finite element method that inclined layers and the mechanical properties of the layers alter local stress fields and also seal pathways. You can visit my poster of this work in this conference and also review the full paper available in this QR code. After this work, we move towards active volcanoes, and a new research problem arises from the next observations. Magma often propagates through inclined rock layers, as we can observe in caldera walls and stratovolcanoes, very common in the Andes. Numerical and analog models usually consider the crust as either an isotropic media or as an heterogeneous sequence, but with horizontal layers. Interpretations of the formation source during magma injection also commonly model the crust as an isotropic media, and efforts have been made to reduce the errors generated by these assumptions, considering the effect of contrasting elastic properties of the host rock, the topography, and the inclination of magmatic sheets. So our research question arises, and is what deformation signals are generated at the surface when a dike propagates through rock layers inclined at different angles. We build different models using the finite element method software console multiphysics. We model a dike as an elliptical cavity emplaced in a homogeneous and elastic crust, but at its tip, the dike encounters a layered sequence inclined at different angles. We run the models varying the angle of inclination, the depth of the dike, tip, the length of the dike, the thickness of the dike, the overpressure of the dike, and the stiffness of the inclined layers, changing its Young moduli. The mesh of the model is composed by triangular elements that the software solves, and in this work, we only analyze the displacement observed at surface, modeled as a free surface with a flat topography. Our main results show that the horizontal displacement observed at surface are asymmetric, with the maximum displacement observed is located above the dipping layers. The stiffness of the layer significantly changes the deformation observed at surface, and in general, the steeper the inclination of the layers, the greater the surface horizontal deformation observed at surface. When we model the inclined layers with lower Young moduli ratios, we observe that lower rigidity contrast between dipping layer generates, in general, larger horizontal surface displacement, especially when the first layer is stiff in comparison to the second layer. About the vertical displacement at surface, we observe that they also are asymmetric, with the maximum displacement observed is located above the dipping layers. The stiffness of the layers also significantly changes the deformation observed at surface. And in general, the steeper the inclination of the layers, the greater the surface vertical deformation. And finally, the effect of rigidity contrast between the dipping layer is less important when measuring vertical displacement at surface in comparison with when we measure horizontal displacement at surface. Here is a summary of our main observation from our results. The surface deformation record above the layered sequence on the right part of the model is accentuated substantially, sometimes by as much as 4 times, compared to above the homogeneous or non-layered sequence located in the left side of the models. When the first layer, or E1, is soft in comparison to the second layer, or E2, the surface deformation recorded is larger than when the first layer, or E1, is stiff in comparison to the second layer. Higher ratios of E1 to E2 when the first layer is softest generate larger surface displacement, and in contrast, lower ratios of E1 to E2 when the first layer is stiffest generate larger surface displacement, although these are not as accentuated as when the first layer is soft, as in point 2. And another general observation, surface deformation increases with dike length. Generally, but not always, surface deformation is greatest in those models with larger inclination of the layers, and surface deformation decreases with emplacement depth. Our preliminary conclusions are as follows. If the rocks through which magma propagates and is in place are inclined at different angles, this will have a significant effect on the deformation recorded at surface during volcanic unrest. Second, the contrast between the mechanical properties of the layers must be considered because of volcanoes. For example, stratovolcanoes are made by alternation of soft and stiff rocks, for example, due to the presence of intercalation of pyroclastic and rocks and lava flows. And finally, our results highlight the importance of considering the local geology when making interpretations of the source of the formations generated during magma injection in active volcanoes. The next step of this research consists in move from finite element method models to analog modeling, building novel experiments to replicate a heterogeneous crust formed by layers dipping at different angles and contrasting mechanical properties intruded by dikes, using gelatin as crust analog and water as magma analog, following the procedure of Kavanagh et al. In different works in this reference. We will make observations from surface deformation using gelatin photoelasticity, and we will measure fluid flow dynamics and gelatin subsurface strain evolution using particle image velocimetry and digital image correlation, respectively. Thanks you for your attention. Any comments or questions are welcome.